Pressure vessels, one of the most important element of any design, because pressure vessels we actually carry gas, fuels. So what happens is that the importance of pressure vessels are enormous. So you need to know how pressure vessels can be designed and what are the aspects of pressure vessels and how you can actually design it. Okay, so understand. So we need to know to get the introduction of pressure vessels. Now, pressure vessels comes with codes and standards because you use pressure vessel everywhere, like gas cylinder, like your even your the bottle you have cold drinks. That is also pressure cylinder, pressure vessels. So where a pressure can be stopped or be stored with a fluid that is termed as pressure vessels. So we come with the pressure vessels design. We have to consider pressure, temperature, corrosion, and the fatigues of fatigue, because the pressure vessel is made up of some material. So there is a chance of fatigue. So you have to consider that. So what are the calculations we do? We do shell calculations. The shell is thick or thin. That depends what type of pressure vessel is. It is a thick pressure vessels or thin pressure vessels. Next is the head design. See, you need to open the pressure vessels, right? So what should the head represent? The opening should be screw type, or it should be a centrifugal type. So there are a lot of things. Nozzle in reinforcement, like nozzle in the sense we have the in our cylinders, gas cylinder, where we have a nozzle and the pressure is the fluid that is butane is put inside the cylinder, and that is LPG actually, that is used for our home cooking. So what we do is that we are making a container which contains some fluid, that could be liquid or that could be gas in gaseous form, which is accumulating some pressure, and the pressure is so much that it could explode. So you have to consider all those things. Fine. Now, what are the common materials? Carbon steel, stainless steel, alloy steel, aluminum, etc. So material selection has to be done with understanding what type of grade of carbon steel are using, what is the moderate conditions, and so on. Everything. Now, fabrication types, we we join pressure vessels using SMAW or GTAW or GMAW. What does that mean? That could be your welding types. Now, why? Because we will be joining two sections and you will joining two sections and making a pressure vessel. So for that you need to have a proper welding type. That's a proper welding type which could which which will not have which will seal the vessels, and it you can use as a pressure container. Performing by generally we do by cold pressing or cold forming pressing die, or sometimes hot rods. That because depending on what we'll be storing, how many days we will be storing, so that actually help us to make some uh, heat treatment process also. Okay, so that's what. Next is we do for NDT, non-destructive testing, radiographic testing for like storing nuclear waste, ultrasonic testing to find out there is a crack or not. If there is a crack, it is harmful or not. There will be a crack, but it is harmful or not. So we have to find out the crack. Next is your magnetic particle testing, which help us to the crack in the surface, and a PT, that is liquid penetration test, actually help us to penetrate and where you can which will show the zone. That means there is a chances of crack, so you can avoid it. That if the penetration zones are if there is a indication that the cracks are more, like in a zone, if a cracks are more, like more than 30%, it is a standard, basic standard, then that zone will be omitted, or that section can be omitted and can go for remanufacturing, starting from furnace to your machine. That means anything can happen. Okay, next. What we use in reactors, like as I say, the nuclear plant, distillation columns, like where we distill the fuel, storage, well, in chemical industries, in oil and gas, we use as a separator, refineries, pipelines, power, aerospace and power. We know that it is used in our aircraft is nothing but it's a pressure vessel only. It is a controlled pressure vessels, but with flow. It's an open pressure vessels, you can say. Nuclear reactors, rocket propellant tanks, like what we used for rockets. So these are the some places where we can use. So there are risks also. What are the risks? The risk may be how we can protect it. What are the we need to go for regular inspections and everything. So there are ASME codes, which ASME standards that has been input, or that has been have to be included while making these things. And this is only way how you can ensure the security of the pressure vessels. Now, next is what are the trends, future trends? We are trying to get pressure vessels with making 3D printers or 3D manufacturing, and we are trying to get more digital monitoring using digital forms like sensors, strain sensors, or it may be your UV sensors, it may be your laser sensors to detect whether there has been some source of inflammation or not. So this is what we do to understand how pressure vessels, and how to protect our pressure vessels for safety, because safety is our first priority. Okay, we will be coming with new topic in next class. Thank you and have a nice day.